Hey guys, Bottom25 here, watching launch of Sentinel-3b atop a Rockot from Plesetsk Cosmodrome in northern Russia. Just turn on my brightness for a moment, just so I can actually see what's happening. As you can see, the Rockot is actually inside this tube because it was originally intended to be a ballistic missile. 20 seconds away from liftoff. Now, I have no idea how long this launch will take. I've never seen one. Hell, I've actually never seen a launch out of Plesetsk. 8, 7. Oh, this should be interesting considering it's a silo almost. 3, 2, 1. Are you kidding me? Do they scrub or something? So I see no telltale ignition. Oh, never mind. Okay. Oh, that looks impressive. You're like, yeah, that... Maybe the footage is out of sync or something, that's fine. See, the vehicle is spinning slightly, but I presume that's just it performing its roll maneuver to line up with the launch azimuth. Oh, you got a yell. Or roar is a better way. And the vehicle is passing through some clouds over Plesetsk. There it is again. That thing actually lifted off and shot up into the sky fairly quickly.
And there we go. We are off. Rockot is hauling itself against the gravity of our planet. The first stage is pushing us away from Earth. We need a lot of firepower to do that. Nick, what's our trajectory?
So at the moment we're heading north-northwest, so we're heading up over the Arctic Ocean, and we're heading in this directory because we want a polar orbit when we finally separate, so that Sentinel-3 will be roughly 98 degrees in inclination, which is the angle from the equator to the orbit.
Philippe, what's happening to your satellite right now?
It's starting its journey. I can tell you it's always I think that launching a satellite in orbit is similar to launching a ship at sea. You know, you have worked for it, you've waited for this moment, and here it comes. Very beautiful pictures that we've been able to witness, I have to say, with a clear sky and voila. We also get, I mean, I think that everybody's been able to see the strength that there is in this launcher. You know, our satellite, once it's in orbit, is in a very smooth environment for what concerns at least the mechanical environment, because it's just floating in the air once up there. But now, for this launcher, you can see with this big boost and all the vibration that goes to it, it's a very bumpy ride, really. It's
It is in the first phase of the flight, isn't it? But right now we have separation of the first stage. We're now burning the second stage, Nick.
Yep, this burns for about 3 minutes, and it takes us right over the North Pole, and at the moment we need to accelerate. So we've gained a little bit of altitude, but we need to go fast enough so that when we stop burning, we can actually stay in orbit.
And if you look at the front of the launch vehicle, you can see the whole fairing. Nick was referring to that earlier. It's the pointy section of the launcher. We don't need it anymore because we are now in space.
I don't know why, but I have a feeling it actually accelerates faster than that.
And we can jettison that. Philippe, we can see your satellite now for the first time.
Yes, but those are simulated pictures, yes, but indeed this is what we can imagine, which is that the spacecraft
much higher.
The teams have seen for the last time when the fairing was closed around it, is now really starting its journey in space, because it's really up there and in the forefront of, as a spearhead of the Breeze launcher.
So we've gone above what's often known as the Kármán line, which is effectively the border with space. It's about 100 kilometers above sea level, 62 miles. What does that actually mean, Nick?
So at this point, the air is so thin that the force required to fly in an aeronautical regime, so like an aeroplane, satellites is more than actually a rocket needs to fly in an astronautics domain. So this is really the rocket science that needs to keep us there, and it's the boundary between aeronautic ending and astronautic beginning.
And it was identified by a Hungarian-American aerospace engineer called Theodor von Karman, and he was born in 1881.
Yes, I am. For those of you who did not know. Okay,
so we're burning the second stage, closer now to the next phase, which will be second stage shutdown. These images that we're looking at, these are computer-generated images, which are a simulation of what's been planned for the flight.
Okay, we've got shutdown of the main engine.
The computer to generate them.
Appear to be still firing.
And the second stage shutdown is coming up.
And separation as a
and this is the scheduled moment now for the upper stage to switch off.
And it has ignited.
And switch on the breeze upper stage. So we've lost the second stage, we've switched on the breeze upper stage, starting the next part of the journey. Breeze is taking the wheel, Philippe. It's going to take, what, about another hour and 15 minutes from now. What's Breeze's job?
Well, the Breeze has the important task to bring our satellite exactly on the precise orbit where it should be. In our case tonight, we want to be at the same altitude as an Sentinel-3a, just a little bit above for the commissioning phase, 10 kilometers above actually. So the satellite has its own engine and can change its orbit, but this costs fuel, and so it's very important that we have a precise orbit right from the beginning, and that's where it's critical to have a performant and let's say on-target third stage like Breeze will very likely do tonight.
It's a little bit like a sophisticated taxi driver. It takes its passengers where they need to go. Nick, it's a fascinating piece of kit, isn't it? Because it's effectively a spacecraft in its own right.
Absolutely, yes. It has to be very autonomous, so it has to really think for itself and be able to decide when to do exactly what it has to do. It has its own onboard computer with guidance, navigation, control. It has its own tracking and telemetry system, so and tell the Russian experts what it's doing and when it's doing it. It actually has the capability to restart its engine multiple times and perform different maneuvers so that it can take its passengers to different orbits or even multiple satellites to different tremendous flexibility, but as you say, it has to be very clever, and it's a spacecraft in its own right.
The Sentinel-3 satellites are a key component in the Sentinel constellation, which of course as a whole provides vital services to the Copernicus program. We're going to take a look now at the kind of services that the Sentinels provide.
With more than half its satellites now launched, the Sentinel constellation is providing a wealth of data on land use, the marine environment, the atmosphere, security, emergencies and climate change. By combining Sentinel satellite data with Earth observations, scientists can develop a clear understanding of many of the vital issues affecting our planet. Sentinel-3, for example, data every day to help scientific projects around the world studying the oceans and the marine environment. Many of these projects, such as EuroHab, which investigates harmful algal blooms or HABs, can only go out to sea at certain intervals once every 2 weeks. Sentinel-3 captures a broad view of the production of phyton. The scientists of EuroHab can then take further measurements to break down which species are and, crucially, which are toxic. At Plymouth Marine Laboratory, an ingenious device called a smart fin is attached to a surfboard temperature of coastal water, and the motion of water is measured using a smart. Back in the lab, these measurements verify and sharpen an interpretation of the data provided by the instruments on board Sentinel-3.
The temperature of the ocean is a fundamental. It controls the physical environment through changes in density together with salinity, which impacts coastal currents. It also controls the biological environment, so the growth and reduction rates of pretty much all marine organisms are temperature dependent.
While a scientist on a small part of the ocean, satellites can cover the entire planet. By combining Sentinel-3's data with measurements taken at sea, and applications are tested. At Plymouth Marine Laboratory, scientists in situ data to determine whether plastic and rubbish accumulation in the ocean can be detected from space.
We are going to do a horizon scanning exercise with all the technologies that are available from Earth observation, and we are considering mainly, because that's our expertise, optical methods, but then we're also considering other remote sensing methods like SAR and as well indirect approaches.
The Sentinel constellation of satellites is at the heart of Europe's far-reaching Copernicus program, providing real-time information 65 days a year on the health of our planet.
The breeze is still burning.
Philippe, this is really important, isn't it? These services are hugely important, particularly as the world becomes more and more conscious of the need for sustainability.
Yes, and I think that as we've seen in the movie, it's about satellite, but also we shall not forget the importance of all the data that have been gathered directly on. Also, what we found with Copernicus is that the data is important, of course, but it's mostly what you do with it is critical. And that's the reason why the Copernicus program is about satellite, but it has also an in-situ component, and then it has a service component. And it's really the three together that are delivering, let's say, the overall value of the program. And let's not forget that our institutional service that have been put in place by the Commission, there is also many commercial companies that are now establishing themselves and that are providing added value services, services that you can buy. And so Copernicus is not only better about environment, a commercial and economic affair.
In a couple of minutes' time, the Breeze upper stage will be scheduled to switch its engine back on again off, for the first of two ballistic phases. Nick, what does ballistic mean? We do hear the word quite frequently, but what does it actually mean, and why do we need two burns for this particular mission?
So a ballistic phase is when there's no additional energy added to the system. So it's like a bullet. When you fire a bullet, it's left to its own devices. You give it an initial kick, the travel is in a ballistic phase. So the reason that we have this ballistic phase is that to do a two-burn maneuver is the most efficient way of making a circular orbit. If you want to, when you start with an elliptical orbit. An elliptical orbit is like an egg shape. The most efficient way to make the whole orbit round is to find furthest point, or the apogee. But you have to wait until you reach that time. So during this phase, there's no additional energy required, so you're in a cruise phase.
And I think I'm right in saying that it's Kepler who identified the elliptical orbit, the motion of the planets?
That's right. Kepler identified the three main orbits from which you can determine the motion of the planets around the Sun and basically any satellite around the planet.
Yeah, about a minute from now.
That's quite amazing, really. It was back in 1571 that he was born. He was a mathematician and an astronomer. Apparently, though, I was reading on Wikipedia that he had smallpox as a child, which left him with crippled hands and very poor eyesight. And apparently he is known as the founder of modern optics and discovered eyeglasses, or helped, or was one of the important people in discovering eyeglasses. So we have him to thank for our glasses. So the Breeze upper stage getting ready to switch its engine on. The scheduled time in 20 seconds. Switch its engine off, I meant to say, of course. Getting close now to the end of this burn. And there we have the scheduled moment now for Breeze to switch its engine off. So we are now in the ballistic phase. We are cruising without the engine, which we will do for about an hour, and before it switches the engine back on again. We are now going to go over to Plesetsk and talk to Bruno Beretti, who is the Sentinel-3 project manager. He's in charge of Sentinel-3, and also to Patricia Lopez, who is the Sentinel-3b launch campaign manager. She's been leading the teams throughout the campaign. Bruno, let's start with you.
That was the launch of Sentinel-3b atop a rocket. I'm Boston 25. Goodbye.
Bruno, you've